want you to put that we are doing lesson 1.4, notes 2. So our second day of notes on lesson 1.4. So that page should have this title, so you understand, so you know what it's about. And today our learning goal is actually the same as it was yesterday, that you can solve an equation in one variable that contains more than one operation. So in other words, it takes more than one step of work to actually solve them. So the first thing we're going to do is give ourselves a reminder. Okay, so write that. We're going to remind ourselves of something. So the reminder is this is something that we should know already, so that's why we're just treating it as a reminder. But when a variable does not have a number in front of it, I'll let you catch up to that. When a variable does not have a number in front of it, does anybody know what it is actually being multiplied by, or what we can multiply it by, so that we can put a number there? Because sometimes it's handy to have a number there. Anybody know what we can multiply? If we have a variable in the equation, and there's not a number in front of it, what's the assumed number that would be there? What can we multiply by that never changes the value? 1. Yeah, there's that property that says multiply by 1, and you still have what you had before you multiplied. So when a variable does not have a number in front of it, we can multiply by 1. In other words, we can insert a 1. So we can multiply it by 1. Sometimes it's going to be a lot handier for us to do that so that we end up getting the right solutions for these. So let's just put a little example here of what this really means. Example. Remember, it's nice to have visuals of things. So here's an example of what I mean. We have this equation, 3 take away x equals 10. We can multiply that. Is the variable got a number in front of it right now? Is the variable being multiplied by anything right now that we can see? No, that 3 is not part of the multiplication. It's part of the expression, but so we could rewrite this like this. We can slip a 1 in there. And it's going to be important that sometimes we do that, because then the other thing we're going to do is change subtraction to add the opposite, so we realize that we really have more than one operation going on here. Even though it looks like there's only one operation, there's really 2 operations going on. Okay? Okay, so I want us to start some practice here. We're just going to practice a couple of problems before I hand out the worksheet today. So we'll let these guys catch up. You guys put that there, and the rest of us, I'm going to move over to the whiteboard here and put the one that we're going to start practicing with. So number 1, we're actually going to solve that equation, 3 minus x equals 10. Okay. So we're going to practice solving. 3 take away x equals 10. Now, if we left it just like it is and we didn't put that 1 in there like we did in our example, and when we inserted that 1, would anybody like to tell me what they think the first move would be in solving this one? What do you think would be the actual first move we would make to solve 3 minus x equals 10?
Subtract 3.
Subtract 3, okay.
No, actually put a
subtraction to addition to add the opposite, okay? And then if we do that, then we can read it backwards, okay? So how many of you agree with Jessie? She says, you know what, when I look at that, I would, she said I could change the subtraction, but her first thought before she even said that was, I would subtract 3 from both sides. How many of you agree that that would be a good first move? Okay, so it actually is a good first move, but before we do that, here's how we're going to show that we actually can get away with doing it. Remember, we can put a 1 in front of the variable when there's not a number there. When it's not being multiplied by something, we can insert a 1 there. And then we're going to do what Jossie was suggesting, which was change the subtraction to add. When you change subtraction to addition, you have to change what was being subtracted to its opposite. What's the opposite of 1x? Negative 1x, yeah, negative 1x. And I like to raise my negative signs up a little bit so I can tell that it's not a subtraction anymore. So I have 3 plus a negative 1x now equals 10. Okay, now I say, remember what this was like solving multi-step equations yesterday. We said, what should we undo first? So should we undo the addition and subtraction first or the multiplication and division? Addition and subtraction?
Multiplication.
Anybody have yesterday's notes handy? What did it say? What did we decide we probably want to do first? Anybody find it? Julia, what do you think what does it say we decided yesterday we thought we should do first?
Addition and subtraction.
We should undo addition and subtraction first, didn't we decided? So that means we would undo the adding 3, because we can read addition backwards. It's negative 1x plus 3, so we should do like Jossie suggested in the beginning, subtract 3 from both sides. Undo the addition first in this one. And now our equation is going to read negative 1x equals what? 7. Okay. What do we do? Are we done?
No.
We have to do one more step, don't we? What do we have to do?
Divide
Divide both sides by?
Negative 1.
By negative 1. Yeah, we got to divide both sides by negative 1. And the negative 1's cancel over here. The x is by itself. A positive divided by a negative is a negative. 7 divided by 1 is
Negative 1.
So it's going to be negative 7, isn't it? Negative 7. Okay, so here's what typically happens when students don't do all of these like extra little steps that I threw in here. I'll show you what would probably happen. There's a couple of different things that would happen when somebody is solving this. You don't have to show this in your notes, but just let me give you a picture of the kinds of things I see when students are trying to solve a problem like this, okay? And I have a couple of different ways that people will do it. Okay, somebody might think that they can read subtraction backwards and say, I gotta add 3 to both sides, okay? That wasn't our first move, was it? Okay. The other thing that people do is they say, I gotta subtract 3, they got that figured out, but then they just bring an x down and say the answer is x equals 7. And why, is that what we got? Did we get x equals 7? We got x equals negative 7. Cody?
Or they would have gotten as a negative x equals 7, or you'd have to divide the negative x by 7 to get x equals 7.
Not divide by 7.
Divide negative x by 7.
What do we know? We'd have to actually divide by negative 1. Nope, not x. We never divide by the variable. We divide by what the variable is being multiplied by. So we would divide by negative 1 next. But typically what happens is they say, I'm just going to ignore that subtraction sign. I'm just going to bring the x down and I'll get, and that's when they end up getting the wrong answer. So that's why it's very helpful for us to make some of these extra moves and insert the 1, change subtraction to add the opposite. Okay, go ahead and try this one then on your own now that we talked about kinds of things that we can do to help us be more successful with it. Okay, go ahead and solve that one. Let's see what we all get for a solution. I think it would be more helpful to use these. Okay, that's some, but anybody willing to offer up their answer? What'd you get, Chelsea?
22.
You got 22. What'd you get, Aurora?
Okay, I want to make sure this is right, but if you have negative 13 minus a number, would it be adding to the 13?
You're gonna add to the 13, but then whatever you add to it, because they were both negative, then the answer will be negative also.
Okay.
Okay? Okay, so. Cody,
I got A equals 4.
you got A equals 4. Okay, you got any other choices here? So either you guys have gotten 22 like Jossie did, or you got 4 like Cody did. Okay, how can we without finishing this, how can I just do a quick prove who's right? Without actually working it out.
Do the check.
I can do the check wrong, couldn't I? Yeah, okay, so let me go over there and do that. Let me see if Jossie's was 22 for A. Oopsie. And Cody's was 4. Which one? Do either of those check out? Okay. 9 take away 22. Oh, I hate when we can't use a calculator. 9 take away 22. Well, I guess we could do this. We could start at 9 on the number line, and we could go back 22 spots, right? Can we do that? Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Look at where we end up.
13.
Negative 13. It appears Jossie's right, doesn't it? Because we ended up at negative 13. What would this be, Cody? 9 take away 4. 5. And you did say positive 4, right? Okay. Does that one check out? No, 5 does not equal negative 13, does it? Okay. So, what do we do first here after I change it to, I can put a 1 in there and I change it to add the opposite? What's our first move? Now I'm starting to solve. What's my first move solving? Devante?
Take away 9.
Take away 9. Okay, this is where, again, maybe this is where it goes wrong for us because we're not very good without our calculators with negatives and positives and, So, Jessie?
You add 9 to 13.
You add 9 to 13 because they're both really going in the same direction, right? And 9 plus 13 is 22, and then they're both negative, so if you're going negative, negative, you're going to end up in negative territory, don't you? So, somewhere along the line, some of us didn't figure out how to do this without the calculator. Negative 1a is what's left on the left side. What's our last move? Aurora?
Divide by negative 1.
Divide by negative 1. So I divide both sides by negative 1. And I do get a negative divided by negative is a positive. 22 divided by 1 is 22. That's how Jessie must have got her answer. Okay. So, to help us be more successful, when there isn't a number in front of the variable, slip a 1 in there, just put it there, put a 1 in there. When the variable is being subtracted, change it to add the opposite, because it will also help you be more successful, okay? So anybody have any questions? Those were the new things we did today. We did this right here. We just made it so it would be easier, friendlier to work with. And then we used all the steps we did yesterday. And notice, it took us 2 steps of work. And for some of you, I'm not seeing that happening on both sides of the equation, both steps. Do I need to? Absolutely. Am I going to stamp papers tomorrow without it? Absolutely not. Okay, let's get our loose leaf paper.